In this tutorial, we'll learn how to create a composite variable in R. So to start off with, here's our sample data file that we'll be working with here today. It's called survey, all lowercase. This is a comma-separated values or .csv file. And we can see here in terms of the different variables we have access to in this data file, this is survey data here. And so we have a survey ID, which is the unique survey ID or respondent ID here. And so here each row represents a unique respondent's responses to this survey. And so here we have different measures and their items, which are represented as variables here. And so for example, we have 3-item job satisfaction measure, which is JobSat1, JobSat2, and JobSat3 here. We have turnover intentions 1, 2, and 3, and then engagement 1, 2, 3, and 4 here. Now, in terms of the numeric responses or scores below each one of these variables, let's say that these correspond to 1 being strongly disagree and 5 being strongly agree. So a Likert type response format that's been converted to a numeric variable here in terms of the responses. So what we're going to be doing is creating a composite variable out of, in this tutorial today, we'll focus on the 4 engagement items. So we're first going to use and estimate internal consistency reliability using Chromebox Alpha to determine whether or not there's sufficient evidence and we should feel justified in terms of creating a composite variable, which is often referred to as an overall scale score variable in the context of creating a composite variable out of a multi-item scale or measure. And we're going to see if we're actually justified in doing so for this 4-item engagement scale here. If you need some background information on estimating internal consistency reliability, I have a separate tutorial called Estimating Internal Consistency Reliability using Chromebox Alpha, and you can check that out. We'll just fly through it in this tutorial to save time so that we can get into the heart of the matter, which is how to create a composite variable, again, which is sometimes called an overall scale score variable. All right, so make sure that you save this file somewhere. I've saved it into my this folder here, which is in my H drive. It's my R workshop folder here. You almost certainly will have saved it into a different folder and a different path on your computer. But here you can see it's called survey, all lowercase here, and it is a comma-separated values file. So now we are ready to get into our studio here, and you can see when we open up the session, we've got console information here about the R history. We don't really need that, so let's go to Edit, Clear Console in the dropdowns. Again, that's Edit, Clear Console. You don't need to do that, but I like to do it to keep things clean and tidy as we start a new session here. All right, the next thing we're going to do is we're going to go to File, New File, R Script in the dropdowns. Again, that's File, New File, and R Script. And this opens up our R Script editor window. And this allows us to write annotations, create code in a more reproducible way and that is more amenable to sharing and collaborating with other people. All right, the first thing I'm going to do is write an annotation using a hashtag here, and then everything that follows on that line will be an annotation. And I'm just going to remind us what we're doing here. We are going to create a composite variable in R. So that's our focus here today. And so what is a composite variable and why might we decide to do it? Well, sometimes it's useful to create a composite variable out of the sum or the mean of multiple variable scores. And so this process results in each case, which by case I mean the observation, the employee, or the individual, or whatever is applicable. Today we're talking about survey respondents being our cases that we're focusing on. And so this process results in each case receiving a composite score based on the sum or the mean of their scores on the variables used to create that composite variable. So you can imagine an example where, for example, we have a direct supervisor that rates each of their team members on 5 dimensions from a performance evaluation measure, which results in 5 separate variables corresponding to the 5 dimensions. A composite variable could be created for each team member by taking the average of the 5 ratings each individual receives, such that the resulting variable represents each team member's overall level of job performance. So why might we create a composite variable in the first place? What's the purpose of doing so? Well, psychological concepts such as employee attitudes, behaviors, or feelings, these are often multifaceted, which means that a single item will likely not capture the full underlying concept or construct space or domain. So if we continue with that performance evaluation example I was giving previously, job performance, for example, is often going to be, and almost, I would venture to say, always going to be multifaceted for a given job, because the conceptual domain often involves a variety of different behavior types, such as customer service, orientation, administrative functions, and so forth. And so by creating a composite variable out of variables that are intended to measure the different subfacets of that conceptual performance domain, we can create an indicator of overall job performance. Now, as I mentioned, we're going to be creating a special type of composite variable today because we're focusing on survey data and specifically multi-item measures, and that is called an overall scale score variable. So it's just a specific type of composite variable. And I'll make a note there, specific type of composite. Okay, and so we use this when we have multi-item scales. And so that's what we're going to be doing here today. All right, so the first thing that we need to do, we have saved our data file somewhere, and now we need to set our working directory so that we can notify where that data file is saved, which just makes it a little bit easier when it comes to reading in that data file as the next step. So I'm going to make a note here that we're going to set our working directory. Okay, we'll use the setWD function here from base R, and as a sole parenthetical argument, I'm going to type in the exact path or location of that survey data file that I showed you at the beginning here. And mine happens to be my H drive R workshop folder. Here is the path where that data file is saved, and at the end of the path is the folder. Almost certainly you're going to have a different path. And so what might be easier is to go to session and then set working directory and choose directory in the dropdowns. Again, that's session, set working directory, choose directory. And then you can just select the folder where the data file is saved. And when you found that, you click open. And then that's a different way that you can set your working directory. In this case, I set it to a folder that doesn't actually contain the data file. I actually want to just set it to this. This actually goes into a subfolder. And so if I go back and I do session, set working directory, choose directory, navigate up here to my R workshop folder. And so this is my H drive, R workshop. Click there. Looks like we're ready to go. I can click open now. This is my working directory. Pretending I don't have this here and I didn't type this in by hand, I could paste this in, and this way it's easy to return to each session, and I can run this really quickly each session without doing the drop downs to set my working directory. All right, so the next thing we're going to do is read in the data. And so we will use the read.csv function, and let's come up with a name for the data frame object, and let's call this data frame object df. And so this is the name of the object we're going to assign the data frame to that we read in. I'm just calling it df. You could call it whatever you want. It's just df for data frame, all lowercase here. Again, you could call it whatever you'd want. And to assign the data frame that we're about to read in to this object, we can use the left-handed arrow operator, which you see pictured here. And so to the right of that left-handed arrow operator, we type in read.csv. That's the name of our read function here from base R, which means we don't need to access a separate package in order to use this function. Again, it's just read.csv, all lowercase. Within the parentheses as our sole parenthetical argument, first type in quotation marks, and then within those quotation marks, type in the exact name of the data file, which in this case is survey, all lowercase here, and I'll actually just copy it, paste it in here, and then just make sure to add the .csv, the comma separated values extension there to it, that .csv. Click run. Let's use the head function here from base R to look at just the first 6 rows of that data frame. So again, that's head, H-E-A-D, all lowercase, and just type in the exact name of our data frame object within the quotation or within the parentheses as our sole parenthetical argument for this function. Click run. Okay, down in our console, we see what we saw before when we were looking at that .csv file opened up in Excel. We saw that we have the survey ID unique identifier variable, and then we have the different variables which correspond to different items from different multi-item measures. And so again, we're going to be focusing on just engagement 1, 2, 3, and 4 today in this tutorial when we learn how to create a composite variable, which in this survey context, again, is an overall scale score variable as an alternative name for it. Okay, so but before we do that, we need to figure out if we're justified in including all 4 engagement items in our computation, which we're going to be creating a composite variable by taking the mean of scores on items for each person or respondent in this case. We need to see if we're justified in using all 4 items. In other words, one thing we can do is determine whether or not these items are internally consistent or homogeneous, or scores on these items are internally consistent or homogeneous. And what I mean by that is internal consistency reliability needs to be sufficiently high. And one way that we can measure internal consistency reliability is through Chromebox Alpha. And so that's what we'll do first here. estimate internal consistency reliability using Chromevox Alpha. Now, there's a whole other tutorial called Estimating Internal Consistency Reliability using Chromevox Alpha that's available that you can check out if you need further background, as I mentioned earlier in this video. But if you just need a quick preview, that's what I'm going to give you right now. We're not going to spend a lot of time in terms of the interpretation of Alpha and the output that we'll receive. So we're going to be using the psych package and specifically the Alpha function. So if you haven't already, make sure that you install and access the psych package. And so to install the package for the first time or to update it, do the install.packages function here from baseR. So that's install.packages all lowercase. And within the parentheses of the function and within quotation marks within those parentheses, type in the exact name of the package, and it's psych all lowercase, PSYCH. I'm not going to run this because it can take a little bit of time, and I've recently installed this psych package. I'm ready to go. If you've already installed it recently, you don't need to run this line. But if you haven't installed that package, go ahead and run that. What you will need to run certainly is the library function, and within the parentheses as a sole parenthetical argument, the exact name of the package that you'd like to access. So after you install it, you need to access it or call up that package so you can access its functions. Okay, so here what you'll see, we don't need to use quotation marks within the library function here. Okay, so click run there. See blue font down here in our console. That's usually a good thing. It looks like we're probably ready. Actually, looks like I moved that down here, move the head function back up there. We are ready to then use the alpha function from the psych package. It's just alpha, all lowercase. Okay, as the first and sole argument for this function, we're going to use what's called bracket or matrix notation. So I'll move quickly through this because, again, if you need background on this, go to the Estimate Internal Consistency Reliability using Chromevox Alpha tutorial, and you'll learn more about how to specify this function. But we've put in the name of the data frame, brackets, and within those brackets, a comma, and to the right of those comma, C function, which is, you can think of being the combined function we use to create a vector. And then we're going to list the names of the 4 items here. In this case, they're specifically items, but just 4 variables that we wish to assess the internal consistency of. Okay, so I'm going to copy engage 1 and make sure you put each one of the items or variables within quotation marks. I'll paste it in there. Outside of the quotation marks, add a comma to separate that variable or item from the second variable argument or item. And then this one's pretty easy, so I'll just do engage 2, add a comma outside of the quotation marks, engage 3, add a comma outside of the quotation marks, and then finally engage 4. Okay, looks like we are ready to go here, and click run because my cursor's on the line there. All right, so here we have our alpha output here. And just for review, I'm going to copy and paste in the exact names, or rather the exact qualitative descriptors for what's considered to be acceptable, good, great, and excellent levels of internal consistency reliability as indicated by Chromevox Alpha. Okay, so first thing we look at the output is the raw alpha. It's 0.84, so that exceeds the typical threshold of 0.70 to be considered acceptable, so that's good. So right off the bat, the 4 engagement items that are intended to measure engagement seem to be relatively homogeneous or internally consistent with one another. But let's go a step further and go to the reliability if an item is dropped table here. Can we improve this alpha of 0.84 if we were to drop any one of these items? Well, if we were to drop engagement 1 and keep the others, alpha would drop to 0.78. Same would happen if we dropped engagement 2 and kept the others, it would drop to 0.78. If we dropped engagement 3, it would drop slightly to 0.82, but it would still get worse. And engagement 4, it would also drop. So the alpha would also get lower. Okay, so what we see here in this reliability if an item is dropped table is that dropping any one of these items wouldn't improve our internal consistency reliability. And so in other words, it just gives us more evidence that this seems to be, at least from a quantitative perspective, and Chromevox Alpha specifically, a pretty homogeneous or internally consistent set of 4 items. So they seem to be measuring the same thing or consistent with each other. Okay, so in this case, we can see because it's 0.84, we could go a step above acceptable and say this is actually good internal consistency reliability for this scale. Okay, but we also, and I'll paste these in, after we look at Chromevox Alpha, we should also look at the actual item content. Okay, and so let's imagine, as I mentioned before, that the response format is strongly disagree to strongly agree. So when people respond reading items, when I'm working, I'm full of energy for engagement 1, they would respond with on a 5-point scale between strongly disagree to strongly agree. And so if I'm thinking about engagement and whether or not these items meet the conceptual definition of engagement, I'd say all 4 do. So when I'm working, I'm full of energy. That sounds like engagement. I complete my work with enthusiasm. That sounds like engagement. I find inspiration in my work. That sounds like someone who's engaged. I have no problem working for long periods of time. That sounds like someone's immersed and engaged within their work. So this corroborates what we found with the raw alpha. So given alpha equal to 0.84 and all 4 items appear to tap into engagement construct, we will retain all 4 items for composite variable that we're about to create. Okay, so this gives us justification here based on these 2 points of evidence, the Chromevox Alpha estimate as well as the actual item content, that it's appropriate to compute the composite variable or create the composite variable using all 4 items here of engagements. Okay, and in other words, the composite variable is going to represent the overall engagement for these people. All right, so create a composite variable, making another annotation there. Okay, so now we are ready to move on to the next phase of this, which is to create that composite variable. What's nice about the script that we're about to write or the code that we're about to write, it'll actually borrow some of the kind of syntax that we're familiar with from the alpha function, okay? And you'll see this as I start typing this out. All right, so the first thing that we're going to do is we need to come up with a name for this new composite variable we're creating. And presumably we want to append, so I'm clicking here on the global environment on the name of the data frame object. We want to append or add this new composite variable, this overall engagement variable, to this existing data frame. Okay, and what we're going to be doing is calculating the row means. So for each row corresponding to each survey respondent, their mean on the 4 engagement items. So for example, it would just be the simple arithmetic mean that we're calculating here. So for this first person here, their scores of 2, 1, 2, and 2 on the engagement score, which 2, let's say that stands for disagree on the strongly disagree to strongly agree 5-point scale. 1 would be strongly disagree. So if you add all these together, 2, 1, 2, 2, and you take the sum and then divide that by 4 to get the arithmetic mean. That's essentially what we're going to be doing behind the scenes here today, except we're going to use a function called the rowMeans function to expedite that process for us. Okay, so first we need to come up with a name for the variable that we wish to append or add to our data frame object. So type in the name of your data frame object followed by the $, and by doing so, we're going to say that whatever we create and type in terms of the variable name is going to be added to this existing data frame here. So that's what the $sign is used for, is this operator allows us to identify the name of a data frame and the name of a variable and show that they're connected to one another or should be connected with one another in the future. So now we can come up to the right of this $sign operator, whatever we'd like to call the new overall engagement score or scale, the overall composite variable that's going to represent overall engagement. So I'm just going to call it engage underscore overall here. So engage underscore overall with a capital E and a capital O. Remember, R is case and space sensitive. And then to assign the composite scores to this variable, I'm going to use the left-handed arrow operator here. And to the right of the left-handed arrow operator, I'm going to use what's called the rowMeans function from base R. And that's rowMeans, all lowercase, except the M in means is capitalized. Okay, so And I said that some of the syntax for this would look familiar in terms of, and the argument structure to what we did with the alpha function. Here's where you're going to see that with the first argument that we're going to use in the rowMeans function. So type in the exact name, and actually I'll just show you how this is exactly the same. We're just going to grab the whole argument structure here. So everything that's within the outer parentheses here, copy it from our alpha function, paste it in. Now, if you were to decide that, oh, actually we should drop one of the variables or the items from the scale, you would just delete it from this syntax, or maybe you have to delete multiple ones. Okay, and so outside the brackets here, so this right here is our first argument of the rowMeans function. So it's the name of our data frame, and then bracket notation or matrix notation, and then after the comma within the brackets, the vector of variables or variable names that we wish to actually use to create our composite variable or calculate the mean of scores in each one of these for each row, where row corresponds to a unique person here. So after the brackets, which is the argument, add a comma to separate it from the second argument. Second argument isn't necessarily required, but we do have missing data. And whenever you have missing data, you want to use the na.rm equals true argument exactly like this. So NA is what missing data are represented as in R. So here you can see some missing data here for turnover intentions for this survey respondent on this row. So what this is saying is remove the turnover, remove the missing data or those values when calculating the rowMeans. That's true. So it's a logical expression or statement here. So all we're saying is if there is missing data, just skip over it and calculate the mean, the rowMean for each case with what data you do have for that person. If you didn't put this there, you would likely get an error message if you had missing data. So just get in the habit of including na.rm equals true and make sure true is all uppercase. Okay, so again, we have two arguments here. The first is specifying the 4 variables. The second one is saying, what do we do if we have missing data? And now you could put your cursor anywhere on one of these 2 lines, or you could highlight the whole thing and click run. We get blue font down here. That usually means things worked out for us. Let's just go and peek at the global environment here in our data frame object. Go all the way over to the right, and now you see we have a new variable called engage_overall that we created. And so you can see the rowMean of, so the mean of 2122 is 1.75. This person has scores of 4444. So of course the average there, the mean is 4.0. And so now everybody has an overall scale score or a composite score on engagement here. So you can think of this as representing overall engagement, whereas each one of these items represents different subfacets or subdimensions of engagement. So that is how you create an overall scale score variable using the rowMeans function.